Okay, look at this 14.6. It says solve the following equations giving answers to 3 decimal places. As this is 3 raised to power x is equals to 20, so 3 raised to power x equals 20. If it would have been something that we can convert them into perfect squares, for example, if I have 27 is equals to 3 raised to power x, so I know I can change this 27 into 3 cube, and then I can say x is equals to 3. Or for example, the question is 16 is equals to 2 raised to power y. We can write 2 raised to power 4 is equals to 2 raised to power y and say that y is equals to 4. But in this case, this is not a perfect square or perfect part number, so we will be using logarithms. So when we apply log on both sides, this is x is equals to log of 20 to base 3. Now this is use of calculator. Let me just get this question is 20. So log of 20 to base 3 is 2.726. So this is how we do it. Let's see another example. Example 15. 5 raised to the power 2x minus 12 into 5 raised to the power x plus 20 is equals to 0, and give your answer to 3 significant figures. Now for ease, if I say let 5 raised to power x equal to y, if this is the case, may I write it like this? Minus 12 into 5 raised to power x plus 20 is equals to 0. Now as we substituted 5 raised to power x equals y, I can write this as y square minus 12y plus 20 is equals to 0, making it a quadratic equation. Now 20 is 1 into 20, 2 into 10. 2 into 10 will give me my factors. So y square minus 2y minus 10y plus 20 is equals to 0. Taking out y common, y minus 2 minus 10, y minus 2 again. So we get y minus 10 into y minus 2 is equals to 0. First factor, second factor, so y is equals to 2 and y is equals to 10. Now we'll switch it back. 5 raised to power x is equals to y and 5 raised to power x is equals to y. So we'll use those two values. One is 10 and the other is 2. So x is equals to log of 10 to base 5 and x is equals to log of 2 to base 5. So these are two possible values. Log 10 to base 5 is 1.43 and log 2 to base 5 is 0.43. So these are the two possible values for this equation. Exercise 14F. Yes, Mohammed. Yes. We'll do them parallel. I'll confirm it from you first. I'll ask you what your school is doing. So if they're planning S1, we'll go for S1. If they're planning for M1, we'll go for M1 first. and alongside we will do these past papers. Like we'll be studying mechanics, for example, and we'll be practicing past paper of pure mathematics. If we choose to do them one by one, that will take too long. P1 done. We'll start, for example, M1 and past paper along with it, parallel. You will be studying this and practicing this based on knowledge of P1. Now these are questions just exactly related to the examples we just did. 2 raised by x is equals to 75. If I use log, this is x is equals to log of 75 to base 2. B part, this is log of 10 to base 3. C part is log of 2 to base 5. D part is 2x is equals to log of 100 to base 4, first step, and second step we'll divide this 2 on the other side, so 1 by 2 log of 100 to base 4. Let's try few examples from question 2. Choose any question. Okay, so this is 4 times 3 raised to power 2x plus 1 plus 17 raised to the power 3x minus 7 is equals to 0. I'll do this after I solve this 2a. Just want to show you one thing before we come on this. 2 raised to power 2x minus 6 into 2 raised to power x plus 5 is equals to 0. The only thing I want you to see is what to substitute. Like in this question we did 5 raised to power x equal to y. So in this question I can see, this is question 2a, I can see that we can use y is equals to 2 raised to power x, right? And the question on left, what should I write? Y is equals to Muhammad, Yahya, Mahad, anyone? What should you substitute it? The question we just did previously, we made 5 raised to the power x equal to y, and in these two questions I am selecting 2 raised to power x equal to y. And what should I write in this part? 2h part. Y is equals to 3 raised to the power x. So this was important. Now we'll convert it. We'll convert and see. Only this is why I'm starting with the simple question 2a, then I'll come to 2h. But now look at this 2a. May I write this as 2 power x and take this 2 outside? Minus 6 2 power x plus 5 is equals to 0. Now the equation is basically simplified in the form of 2 raised to power x. And 2 raised to power x is y. So this becomes y square minus 6y plus 5 is equals to 0. Now this is a simple quadratic equation. Y square minus 2y to make 5 we do not have midterms, so we'll go for quadratic formula. Minus b plus minus square root b square minus 4ac over 2a. minus into minus x plus minus square root b square minus 4 into a into c over 2a. And using calculator, five and 1, there were factors 5 and the other factor is 1. So may I write y is equals to 5 and 1, and y was 2 raised to power x. 2 raised to power x is equals to 5, x is equals to log of 5 to base 2. On the other hand, 2 raised to power x is equals to 1, x is equals to log of 1 to base 2. So x is 0 and log of 5 to base 2 makes it 2.3 to 1. Any confusion in this part? 2a. Okay, now h part. We are substituting y is equals to 3 raised to power x and simplifying for this expression. So 4 times. Now this is powers only add up when they are actually multiplied. So 2 raised to power x multiplied by 3 raised to power 1. Basis same, powers add in this reverse rule. Plus 17, 3 raised to power x is already simplified. 4. Now this is 3x square. So may I write y square into 3 plus 17y minus 7 is equals to 0. 4 3 times 12 y square plus 17y minus 7 is equals to 0. Minus b plus minus square root b square minus 4ac over 2a. Did you get it? How we converted it into y? Sort of. Okay. Is anyone using calculator alongside? Okay. Now this is going to be interesting. I was waiting for a negative answer. These are values of y. Now we have to write y is equals to 3 raised to power x. Y is equal to 3 raised to power x. On the other side, y is equals to 3 raised to power x. So first one is 1 by 3 and second one is minus 7 by 4. On left hand side this is easy, so I'm doing it without using logarithms. So this is 3 raised to power x is equal to 3 raised to power minus 1. So I can say x is equals to minus 1. On the other hand, I will say rejected. Why so? If you write 3 raised to power x and you choose any number in form of x, it can never be negative. The answer can never be negative. Whatever power you write above 3, the answer can never be negative. Other way, if you still try to convert it into logarithmic form, you will be writing x is equals to log of negative 7 by 4 to base 3. And do you remember, we discussed when we write log a b, we said a is greater than 0, b is greater than 0. That means both of them are always positive. Secondly, the denominator that cannot be equal to 1. So this is actually negative, that is why it is rejected. Any ambiguity. And did you connect your y? I can do that again if there's any confusion, converting this into y. 3 raised by 2x plus 1. Let's do it quickly. We can write this as 2x into 3 raised by 1. Base is same power add, reverse of this. Then I can write 3 raised by x squared into 3 raised to power 1. 3 raised by x was y. So this is 3y square. This is how we got this 3y square. Yes. Sure. Okay. Yes. So keep writing. There's one more way how you can do that. I was avoiding this, but I think that will be helpful for you. For example, a power x is equals to b. Now consider this, that this is your car's steering. They lie there, and this is the line. So I'm going to turn towards left. When I turn it towards left, what happens? X actually lands on this line, a goes on the other side, b raises up. Log. What if the question is written the other way around? For example, y is equals to z raised to power p. Still consider it that it is a steering. What you have to do is you always bring the power down. You always bring the power down. Now I'll be turning it towards right. So when you turn it towards right, what happens? P lands here, z goes on the other side, y is lifted up, log. So this is a small switch. Write it multiple times and you'll be confident. A raised to power b is equals to c, d raised to power e is equals to f, g raised to power h is equals to I. So when you change it into logarithmic form, b comes down, log c to base a, e comes down, log f to base d, h comes down, log of I to base g. What happens in reverse? What is in the base stays in the base. A raised to power b is equal to c, d raised to power e is equals to f, g raised to power h is equals to I. Use half A4 and write as many questions as you can and convert them to and fro. Index to logarithmic and logarithmic to index back. For example, we have 4 raised to power x is equals to 7. So this becomes x is equals to log 7 to base 4. Now there is one other way you can do it. 4 raised to power x is equals to 7. What should you do? You should apply log on both sides. So this is log of 4 raised to power x is equals to log of 7. We applied log on both sides. Now using power law, this x comes outside. X log 4 is equals to log of 7. Now we were working for x, so I'm dividing this on the other side. So x is equals to log of 7 divided by log of 4. And we know we can write it in simplified form, which is x is equals to log of 7 to base 4. This into this. You may choose any path, final answer will be same. So to avoid these many steps, it's better you write few questions, random questions. 7 raised to power y is equals to 11. So it is y is equals to log of 11 to base 7. Getting it? You will be confident when you write it, not to read it. Yeah. When you write, suppose y is equals to log of 9, it is understood when there's nothing, it is understood that it is 10, and we can write it as LG9 short form. And when you have e exponential, suppose e raised to power x is equals to 7, so this is x is equals to log 7 to base e. These are the two standards, one of 10 and one of e. We can write ln7. You'll find that button on your calculator. Ln means ln is actually equal to ln x is equals to log x to base e. So this is ln x. This is just ease of writing. E. I'll share this picture in group, how it looks like. And yes, definitely you should know where it lies in your machine. Okay. I've shared this is ln right next to log. And this is a simple one, but a bit older version. Okay. Yeah, we'll be using it when we have e in our base. So this right here, e raised to power x is equals to 9. If this is the case, I'll write x is equals to log 9 to base e. Now I know to base e, this is basically ln. So you can either punch in this thing or this in your calculator, both will give you same answer. Sometimes the examiner tells you that show that this question simplifies to this form. Even then this is helpful. Okay, question 2, G part. 3 raised to power 2x plus 1 minus 26 into 3 raised to power x minus 9 is equals to 0. This time I will try to do it directly but slowly so you don't miss it. I say let y is equals to 3 raised to power x, and I'm writing y square multiplied by 3 minus 26y minus 9. Can you see through this that this is 3y square? This thing 3 raised to power 2x plus 1, if something is added, I can see that this was previously multiplied. Bases same, powers add up, and then I can see this that this is 3x square, so y square into 3, and writing it as 3y square directly. If this would have been 3 2x minus 1, what will we do? We'll write y square over 3. There's no need you do it directly. You can go step by step. This depends on your practice. Getting the point? So 3y common, y minus 9 plus 1 common, y minus 9 is equals to 0. 3y plus 1, y minus 9 is equals to 0. So first thing is 3y plus 1 equal to 0. Second is y minus 9 is equals to 0, and y equals 9 first. Y is equal to minus 1 by 3 second. And what was y? Y was 3 raised to power x. So 3 raised to power x is equals to negative 1 by 3, rejected because it is negative. And 3 raised to power x equals 9. We can do this without log. 3 raised to power x equals 3 raised to power 2. Therefore, x is equals to 2. It is purely your choice. No matter how you do it, you will get the same answer. Now, using the rules of logarithms, may I write this as 3 square to base 3? Then bringing this 2 outside using power law. This is 2 log 3 to base 3. Now 3 log 3 becomes 1. So that is 2 again. So 2 and 2, no matter how you do it, your final answer will be same. How is Yahya? I'm forgetting his voice. Yahya doing good? I'm living on the edge. Oh, okay. This was a TV show, Living on the Edge. Only the tough ones could reach there. Question number 3 says, solve the following equation giving your answers to 3 significant figures. When I see these such things, I get happy because this cannot be done without calculator. And having a calculator alongside makes the question easy. Now this is x plus 1 to base 3 and there is 2000. So I'm applying log. Bringing this power down, x plus 1 is equals to log of 2000 to base 3. X is equals to log of 2000 to base 3 minus 1. And there we go with our machines. This is log of 2000 to base 3 is 6.918 minus 1 is 5.918 to 3 decimal places 519. Question 3b part. Log of x minus 3 to base 5 is equals to minus 1. Now this is logarithmic form. I'm changing it into index form. Taking this 5 on the other side, x minus 3 is equals to 5 raised to power minus 1. So x is equals to 5 raised to power minus 1 could be written as 1 by 5 and minus 3 on the other side becomes plus 3. 16 by 5. Getting it? Any confusion? Yes. It will get a little more messy. A little. Not too much. We did 3A and B. And 4B, let me see. Yes. See, we did log A to base B. When I've written this, you know both of these are positive. B cannot be 1. We did log of x square to base y, and we know this is power law. What we did is log x plus log y. If we see the addition sign, we know they are being multiplied. When you know these rules and you've practiced them, then it will become easier. whenever you have a look at the question, you'll know what to do. Like you just did, 4 raised to the power 2x minus 10 into 4 raised to power x plus 16 is equals to 0. Now without even reading this statement, you know you have to write y is equal to 4 raised to power x. And we can write y square minus 10y plus 16 is equals to 0. Am I wrong? Without even reading the statement, you'll know, this will click in your mind that you have to go for this. Then midterm breaking, y square minus 8y minus 2y plus 16 is equals to 0. Y minus 8 minus 2 into y minus 8, y minus 2 into y minus 8, and one is y is equals to 2, the other is y is equals to 8. Now in this case both are positive, so we'll choose both. So 4 raised to power x is equals to 2, one thing. 4 raised to power x is equals to 8, yes. And now again, because these are such numbers, we can convert them into index form. We can solve them either way using logarithms or without that. If we choose to use logarithm, this will be log of 2 to base 4, whatever the answer is. On the other side, this would be log of 8 to base 4, whatever the answer is. Calculator will do this part. If you are doing it without using the calculator, what you can do is, I'm converting this 4 into 2 square. 2 square power x is equals to 2. So we can write 2 raised by 2x is equal to 2 raised by 1. So now we know bases are same and there's a sign of equality. So therefore 2x is equals to 1 and x is equals to 1 by 2. Now use your calculator and let me know what this gives you. Log 2 to base 4. Waiting for the answer. Use your calculator and let me know what gives. Yeah. .5. So we have the same answer, right? 0.5 and 1 by 2. Now these are two different methods. Now look at this third one. X is equals to log of 2 to base 4, right? And if I convert this into powers, this will become 2 square. Now remember this, when this 2 comes out, it becomes reciprocal. So 1 by 2 into log of 2 to base 2. Now this thing in bracket is actually 1. So your final answer is 1 by 2. So all three methods give you same answer. Now this is your choice. If I have to solve this without using calculator, this is log of 8 to base 4. I can write log 2 cube and 2 square. When this 3 comes out, it stays as it is. When this 2 comes out, it is reciprocated. So log of 2 to base 2. Final answer is 3 by 2. That is 1.5. So this x is 1.5. So 1 by 2 and 3 by 2. These are the two answers for this statement. Sure, why not? That would be better if that is the current topic. Just share it, I'll solve it. G and H. One more class will finish this question. Where did you send it? Not yet. Yeah, got it. Let me write this question. Okay, you'll help me solve it. Y is equals to what? Just 3 to power of x. Okay. So 3 raised to power 2x plus 2 plus 3 is equals to 28 into 3 power x. Are we good? First step. Second step. We are trying to isolate 3 raised to power x. So this becomes 3 raised to power 2x multiplied by 3 raised to power 2. Next step. 3 raised to power 2x could be written as y square. So this is y square and 3 square is 9. So 9y square plus 3 is equals to 28y. Now this is a smooth quadratic equation. Clear? Let's complete it. 9. Sure, do share them. Do share them. Nine y minus 3 minus 1 y minus 3 9y minus 1 into y minus 3. So first is 1 by 9, the other is 3. 3 raised to power x is equals to 1 by 9. 3 raised to power x is equal to 3. Now see, we don't have to use logarithms every time. So this is 3 raised to power x is equal to 3 raised to power minus 2. Therefore x is equals to minus 2. On the other hand, x is equals to 1. Now do not forget to recheck. No need in this case, there's no logarithms. Okay, I got your next question. Sorry, Mahad, what did you say? No. In this case, no. Graphical calculator would help you in sketching graphs, looking at them. You don't have to buy it. You don't have to buy it. You use your... No. Just use your basic calculator and be good with it. That would be more than enough. Just buy a simple one which gives you the value of, let me check, tan 30, like in fractions form. Tan 30 is square root 3 by 3. So it should not give you answers in decimals. Sometimes the examiner requires to leave answer in exact form. Okay, now if this is the question, I'm going for square root on both sides. So I can write e raised to power x. Yes, e raised to power x is equals to e raised to power minus x. What did you do, Mohammed? Why did you do that? Let me think. Do this. I'm thinking what to do next. So e raised to power x, and this should be 1 over e raised to power x, and I'm multiplying it back So e raised to power x multiplied by e raised to power x is equals to 1, basis same, powers add. So e raised to power 2x equals 1. Now we can apply logarithms. 2x is equals to log 1 to base e. Whenever it is log 1, that is 0. So 2x equals 0, x is equals to 0. Clear? Yeah. Do share it, and whatever method you choose, you will always get the same answer. And you may have different paths. Sure. Yeah, no issues. He used the algebraic expression a square minus 2ab plus b square. But I think that is a bit lengthy, and this one was shorter than this. And if you need to replace, as you are writing here, y, this is e raised to power x minus e raised to power minus x is equals to 0. So if you substitute y is equal to e raised to power x, this goes like this: y minus 1 over y is equals to 0. Now you take the LCM. Y square minus 1 is equals to over y is equals to 0, and y square minus 1 equals 0. Y square is equals to 1, square root on both sides. Y is equals to plus minus 1, and e raised to power x is equal to 1, and e raised to power x is equal to minus 1. This is rejected. Why is it rejected? E raised to power anything cannot be negative. And when we come here, x is equals to log of 1 to base e, x is equals to 0. So you can do it by any method, substituting with y, taking square root, or expanding it using algebraic formula. Makes no difference. In our next class, we'll be looking at this ln thing, which is log to base e. The rules are 100% the same. This is only one introduction. For example, we have this ln x is equal to 3. So ln x is equal to 3. When this ln goes on other side, this is e raised to power 3, because it is understood that ln means log with base e. So x is equal to e raised to power 3. Nothing new. All the rules are same. Let me see. Modeling is just like quadratic graphs, cubic graphs. This is a simple equation, and we'll be sketching them, drawing them. That's what modeling is. These are the only two things, ln and modeling, and then we'll be done with this book. You see this model. So what happens when t is increasing? This function is giving you increasing function, so it is increasing. This is the model.